All right, we're doing chapter 5, section 5, side, and hypotenuse leg. So we covered side, angle side. This is two more ways you can prove that triangles are congruent. So SSS stands for side, and HL stands for hypotenuse leg, which I will go over what that means. All right, side congruency theorem. This, again, states that if all three sides of one triangle are congruent to the other triangle, all three sides to the other triangle, then they're both going to be congruent triangles. So when you're looking at triangle congruency, make sure you're understanding which sides are congruent to another. So I'm going to go ahead and write the congruency statement. If you're looking at it, you should be able to tell which ones are congruent by looking at the congruency symbols. So you have these two sides are going to be congruent. These sides are going to be congruent because they have two congruency marks. And then
Can you please send Amelia Padilla down? She's leaving.
She's on her way.
Thank you.
And then those are your other two congruency sides. So I'm going to go ahead and write my congruency statement. It would be triangle A, B, C. So I'm going from side 1 to side 2, then to side 3. Is congruent to side 1, which is triangle DE, and then going to F. Okay. So make sure you're following your congruency marks. If not, it will be wrong. Okay, also be able to determine what sides are congruent. So I will go ahead and write which sides are congruent. I have AB. Segment AB is congruent to DE. And I can use these when I'm looking at it. AB and DE are in the same area. And then I have BC is congruent to EF. Here's BC, here's EF. And then last, I'm going to have CA is congruent to DF. Keep in mind, yes, you can switch the order of the letters as long as the two sides, the two vertices, are together on that one side. All right, looking at these triangles, this is determine whether the congruent triangles are true. The congruent statement is true. Explain your reasoning. So looking at this, we're just going to go ahead. I'm going to highlight what's congruent. Here's side 1 is going to be with side 1, which if I'm looking at it, I have DG. Here's my D, here's my G. Is that congruent to HK? Yes. Again, it's written in the same position on my statement. Looking at the next one, I have FD and JH. FD and JH should be congruent. Here's FD, here's JH. Yes, that's good. And then my other side is FG and JK. FG and JK should be congruent. FG and JK are. Okay, so again, I'm just going to write them out. I have DF is congruent to HJ. Then I have FG is congruent to JK. And then I have DF is congruent to HK. So are these congruent, yes or no? Yes, by what? What would I use to prove that these are congruent triangles? Good. Side. Okay, you could just write side. That's fine. I understand what you mean. All right, looking at the next example, very similar to the one we did before. It says determine whether, decide whether the congruent statement is true. So same thing as we did before. Let's go ahead and look at my congruency statement. I'm going to go ahead and look at AB and CA. Those should be congruent. AC and CA is right here. I'm going to make one congruency mark. So I know AC is going to be congruent to CA, and its 9 is congruent to 9. Is that true? Yes, it is. Looking at the next one, I have CB is going to be congruent to AD. CB is right here. I'm going to make 2 marks. AD is right here, and that's 7 is congruent to 7. So far, so good. And then the last one, I have AB is congruent to CD. So AB, is that congruent to CD? Is 3 congruent to 4? Good, no. So this is going to be no. Okay, they are not congruent because of this statement here. It's going to be no, they're not congruent. All right, looking at example number 3, determine whether a congruent statement is true. Explain your reasoning. Go ahead and try this one on your own, and then I'll go over it. All right, let's go ahead and check. All right, checking. Let's see what we have. We have QP and RS. So QP and RS. I'm just going to highlight the marks. Okay, so good. QP is congruent to RS. Let's go ahead and look at PT and ST. PT is right here. Is that congruent to ST? Yes, it is. So I have PT is congruent to ST. And then the last one, I'm going to have QT and RT. So looking at it, QT, RT, those are congruent. So yes, this is a yes by what? Good, side, side, side. All right, looking at this one, it says, explain why the bench with the diagonal support is stable, while the one without the support can collapse. Can anybody tell me why they think the one with the diagonal support is more stable? Any ideas? Why with the one with the diagonal? Yes.
Because the triangle is a strong shape of all shapes.
Okay, kind of on the right track. So when you have 2 congruent triangles, it gives more support, okay? So yes, if you guys have ever like sat on one of those wooden benches without the support and you kind of rock side to side, it's gonna collapse. So when you're looking at this diagram, when you have 2 congruent triangles, it gives more support. Okay, it's going to give more support than if it did not have that support in the middle. So if you actually look at the football boy bench, the benches on the field, I believe they have not only 1 but 2 support beams in the middle. But if you were to look at this one, if you were to kind of like rock side to side, it will just completely collapse because it's not sturdy enough. All right, parts of a right triangle. We should know what these parts are. We should know whenever we have a right triangle, we have a little symbol right here that shows you it's a right triangle. When you're looking at a right triangle, you have 2 legs and a hypotenuse. Okay, we should always know your hypotenuse is always going to be the opposite the right angle. Okay, so your hypotenuse is opposite the right angle. Okay, and you should also know that your hypotenuse is the longest side of the triangle. Okay, so your hypotenuse is the longest side. And again, it is opposite of your right angle. So when you think of HL, hypotenuse leg, that means your hypotenuse has to be congruent to your other hypotenuse. Your hypotenuse, leg, and it only has to have 1 leg. It doesn't matter which leg. as long as your legs for your two triangles are congruent. Looking at the next one, hypotenuse leg. Let me explain what this is. If the hypotenuse and a leg, keep in mind a leg just means one leg of one right triangle, we're specifically talking about right triangles, are congruent to the hypotenuse and a leg of another. Again, we're specifically talking about right triangles, and it has to be one leg. So I'm going to draw a diagram and show you what that means. So if I were to give you two right triangles, here's one. Here's another. Let's call this A, B, C, D, E, F. My hypotenuse must be congruent and one leg, only one. So I would write this as a congruency statement as triangle A, B, C is congruent to triangle. How would I write the second one? A, B, C. How would I write my second part of my congruency statement? Say it one more time. Who said it? EFD, sorry. EFD, this is an F. Good. Okay, so again, looking at it, you need to understand AC is congruent to ED. Okay, this is my hypotenuse. And I only need one leg to prove that it's HL. So I have two legs, which is AB would be congruent to EF, or I can say BC is congruent to DF. I only need one to prove that it's hypotenuse leg. Keep in mind, these are my legs. I only need one to prove that it's HL. I don't need two. So if they said, okay, here's your hypotenuse, that's good. And if they only gave me this leg right here, I can prove that it is a congruent triangle using HL. Again, you just need a hypotenuse and one leg, not two, just one, to prove that it's HL. All right, looking at this one, it says triangle JKL has these vertices and triangle RST has these vertices. Graph the triangles in the same coordinate plane and show that they are congruent. From here on out, when you guys are graphing, you have to make sure you're labeling your points. So these vertices, this point right here should be labeled as point J. This should be point K and point L. So let me show you what that means. I'm going to go ahead and just highlight which ones go with which. These are my purple ones. This will be my blue dots. So graphing it, I'm going to have -3, 2, which is right here. Please make sure you put a J. Label it. Then I'm going to have 0, -2. This will then be K. And then L would be -3, -8. This is going to go off a little. This will probably be about right here. Okay, so J to K. And K to L. Okay, please label your points. Now looking at the next one, I have 10, 0, which is R. 10, -3, which is S. And 4, 0, which is T. All right, they want me to figure out, are these sides congruent? So when you're looking at it, I'm going to go ahead. The easiest way to do it right now is just to count your horizontal and your vertical lines. So that's the easiest way I'm going to do. I'm just going to count 1, 2, 3. I have 3 up here. 1, 2, 3, 4, 5, 6. And then I'm going to count this side. 1, 2, 3, 4, 5, 6. And 1, 2, 3. Are these right triangles? Yes. Okay, they're perpendicular to each other. And how would I find the measurement of my hypotenuse? I know that my sides are congruent. So right now I have a side triangle, but I need to figure out if my hypotenuse is congruent. How would I find that out? Yeah. Good. So you can use the distance formula. That's fine if you remember it. Or if you guys know the Pythagorean theorem, you can use that as well because they are right triangles. So if you don't know what that is or how to use it, the formula is a squared plus b squared equals c squared, where a and b are your legs and c is your hypotenuse. Okay, it has to be labeled that way. So I know what my sides are. Right now I have 6 squared plus 3 squared equals, I don't know what my hypotenuse is squared. And then we're just going to go ahead and solve it out. What's 6 squared? 36 plus 3 squared is 9 equals x squared. Adding these two together, I'm going to get 45 equals x squared. How do you get rid of a squared? The opposite of squaring something is? Good. You find the square root. So taking the square root of 45, is that a perfect root? No. So I need to simplify it. Simplifying this root. What two numbers multiply to give me 45? Yes. 9 and 5. So right now I have 9 and 5. Keep in mind I'm keeping them in my radical because I did not pull anything perfect out. However, do I have a perfect root here? Yes. This is going to change into a 3 as a whole. So right now I have my answer. My hypotenuse equals 3 radical 5. So I'm going to write it 3 radical 5 here. 3 radical 5 here. I can prove these congruent using side, 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 or I can prove these to be congruent using hypotenuse leg. Again, keep in mind with hypotenuse leg, HL, I only need one leg and a hypotenuse. So yes, we found all sides, but I could use HL for this. So let's go ahead and write what's congruent. Looking at what's congruent, I have JK is congruent to what? I would have RS. And then I have JL is congruent to TR. And then I have LK is congruent to TS. And if I were to write my congruency statement, I would have triangle JKL is congruent to triangle RST. All right, questions on this one? Questions, comments, concerns? Okay. All right, looking at this one, it says, is there enough information to prove that the triangles are congruent? If there is, state the postulate or theorem. So looking at this one, I'm going to go ahead and figure it out. I know this is written in a light color, so I'm just going to kind of trace over it. Keep in mind they're not saying they're congruent. So now we need to determine what's congruent. So looking at the diagram, can someone tell me what legs are congruent? If any, yes.
GH and JK.
Good. GH is congruent to JK. And are there any hypotenuse that are congruent? Is my hypotenuse congruent, yes or no? Yes. Okay, so it's opposite my right angle. And I have FH is congruent to HK. This is my hypotenuse. This is my one leg that's congruent. So are these triangles congruent? Yes, using what? Hypotenuse leg theorem. Good. Okay, you could just put HL is fine.
Can you also look at it by side angle side?
Side, angle, side. No, you cannot. because if it was side angle side, they would have to state that this angle is congruent to this one. But because there's no congruency angle and they're not vertical, I can't write that. Now if they said this side right here, I'll write it in orange, this one, and they didn't give me this, I could say that this is congruent using side angle side. Okay, so if this side, they're giving me my right angle and this side was congruent, then I could say side angle side, but that's not what they're giving me, so I have to use what's given. All right, and the last one is a proof. This one should be more on the easier side. So looking at this, first go ahead and write down what's given. I have WY is congruent to XZ. I have WZ is perpendicular to ZY. And then I have XY is perpendicular to ZY. And this is all given. Let's just make sure everything's drawn where it should be. Okay, they're saying WY is congruent to ZY, which they gave me. Then they're saying WZ is congruent to ZY, and then they're saying XY is congruent to YZ, which is true. Okay, this is the initial diagram up here. So looking at it, this is a right angle, these are right triangles. They're giving me my hypotenuse. What else do I have to find to prove that they're congruent? Jonah?
One of the legs.
One of the legs. Okay, so one of my legs. This is my hypotenuse, which is right here and right here. My legs are what's in blue. Which leg can I know? Which leg do I know is going to be congruent? Yes.
The one that connects the right ones.
Tell me the side. What side would that be?
WZ and XY.
WZ and XY, what can I say to prove that those are congruent? WZ and XY, how would I prove that those are congruent? Is there any particular theorem for those? Keep in mind, look at it up here if you have to. They're on opposite sides. So I wouldn't necessarily use those. Yeah.
You would use ZY or YZ because it's the same line.
Good. So if you're looking at it, ZY and YZ are overlapping. So they're sharing a side, so I could use that as what's congruent right off the bat. So 2, I would say ZY is going to be congruent to YZ. How do I know that they're congruent? Yes. They're reflexive. Okay, keep in mind it's different than symmetric. This is going to be reflexive because it's the same side with the same side. So for this one, it's reflexive property. And because I proved that they're congruent, now what would I use as my last one? I can prove that they're congruent triangles now, correct?
Yeah.
Yeah. I can prove that they're congruent using what? Good. So I can prove that triangle WYZ is congruent to triangle XZY by HL, hypotenuse leg. Questions on this one? Yes, you guys will have proofs on your test. Questions, comments, concerns? You guys have homework on big ideas. The only thing you have to show work for is your proofs, which is 9, 10, and 11, and you must write it out. Okay, so write out your proofs. You guys can go ahead and start the homework.